Unit 1, transformations. Reflections. A reflection is a mirror image of a shape or a figure. This would be an example of a reflection across the x-axis. This would be an example of a reflection across the y-axis. Transversal is a line that crosses at least two other lines. The two lines are usually parallel lines, and that would be the transversal, the red line. Transformed image. It's a changing shape using rotation, reflection, transformation, or dilation. Alternate exterior angles. Angles that are formed on opposite sides of a transversal line which lie in different parallel lines. These would be the alternate exterior angles. Dilations. A dilation is to make a shape or a figure smaller or larger. In this case, the red triangle was dilated to make bigger into the blue triangle. Complementary angles. Complementary angles are two angles that sum up to make 90 degrees. Like for example, this B and A, when added, would equal 90 degrees. Image. An image is the new position of a point, a line segment, or a figure after transformation. In this case, the figure was enlarged, was dilated to be made bigger. Translations. A translation is the moving of a shape without the use of reflections or rotation. Translations are rigid transformations. Translations are congruent and similar. The formula for translation is that. And this would be an example of it. The blue triangle was translated to be the red triangle. Coordinate plane. A coordinate plane has an x-axis and a y-axis that intersect at an origin. They usually have four quadrants, which is the first one, the second one, the third one, and the fourth one. A vector has magnitude, which is its length, and a direction. This would be the magnitude, this would be the vector, and they usually have a head and a tail and a direction. Alternate interior angles. An angle that are formed on opposite sides of a transversal in the inside of two lines. The two lines are alternate interior angles. Those would be the alternate interior angles. And as you can see, the two parallel lines and the transversal line would be right here. Degrees. A unit used to measure angles. Corresponding angles. When two lines are crossed by another line, the angle in matching corners are called corresponding angles. The ones that are a bit reddish would be the corresponding angles. Congruence transformations. The transformations that do not change the shape or size of a figure. Transformations. This would be a translation, a rotation, and a reflection. Vertical angles. Each of the pairs of opposite angles made by two intersecting lines. Acute angles. An angle that measures less than 90 degrees. This would be an acute angle because if it were over here, it would be a 90-degree angle, but it's less than 90 degrees. Ordered pairs. Two numbers that are written in specific order to plot a point on a coordinate plane. This would be the x-coordinate, which goes on the x-axis, and this would be the y-coordinate that goes on the y-axis, and together they make an ordered pair. Scale factor. How much you increase or decrease a figure size. This usually is involved in dilation. Rigid transformations. A transformation that does not change the object's size or shape. Rigid transformations include translation, rotation, and reflection. Parallel lines. Parallel lines are lines that never intersect with each other. That would be an example of parallel lines. Supplementary angles. Angles whose sum is 180 degrees. If you add 150 degrees plus 30 degrees, you would get 180 degrees. Similarity transformations. A transformation that is not the same size or shape. Similarity transformation. The before would be the blue and the after would be the red. Obtuse angle. An angle that measures more than 90 degrees but is less than 180 degrees. That would be an example of an obtuse angle. Straight angle. An angle that is 180 degrees, which is a straight line. Pre-image. The original position of a figure before a transformation. Pre-image and the image. Corresponding points. Points that correspond with each other. Point A and point A prime correspond to each other. Point A would correspond to point A over here. Well, when is
It's gonna do
point A over here? Rotations. A rotation is the turning of a shape or figure around the axis of at a certain degree. Rotations are rigid transformations. Rotations are congruent and similar. The formula of a 90-degree clockwise rotation is that the formula of a 90 degrees counterclockwise rotation is that the formula of a 180 degrees rotation is over here. This would be a rotation.
Unit 2, functions. What is a function? For each input, there must be an output. This is an example. What are ways of interpreting functions? You can interpret functions in many ways, but the main ones are interpreting them by tables, graphs, equations, or ordered pairs. Linear functions include lines that you can actually see are straight and make a linear whatever. Non-linear functions, as you can see, are not very linear and have very, bumpy rides. Function rules. You must figure out what y equals in most cases. For example, here we have a chart. Now the function rule is y equals mx plus 2. You could tell that this is right because if you were to substitute the numbers in, x 2 plus 2 equals 4, which is y. So that's how you know. The slope is the steepness of a line. As you can see here, this would have a positive slope, because from going left to right, the line just goes up. In variables and slope-intercept form, the variable used for slope would equal m. These are the different kinds of slopes. As you can see here, this would be a positive slope because from going left to right, the line only increases. From here, this would be a negative slope because from going left to right, the line decreases. This has no slope because there is no steepness in the line. And this one is undefined because you really can't tell what the slope is.
I need this, right?
This is the slope-intercept form, and it's y equals mx plus b. B standing for the y-intercept and m standing for the slope.
You guys don't.
If you were to put it in a graph, this is how it would look like. And if you were to substitute in all the variables, 3, which is the y value, equals the slope right here, which is 3, 2, plus 2, which is times 2, which is the x value. And since the y-intercept is 0, we don't need to add anything. But if anything, this would be the slope-intercept form for this graph.
Unit 3, linear equations.
Coefficient, the number that is multiplied by the variable. Like 4 is multiplied by x.
Coincident. Two lines or shapes that lay directly on top of each other.
Collinear, points lying in the same straight line.
Collecting like terms. Combining numbers that have the same variable, like 3a and 4a are combined, and 12 and 8 are combined.
Combining like terms. Putting alike terms together.
like 4y minus 2y, which is 2y, and then 5x stays the same because there's no other alike terms. So yeah, 2y plus 5x is the answer.
Dependent variable. The variable that depends on something such as y is dependent on x.
Distributive property is distributing the number outside the parentheses, but the number is inside the parentheses by multiplying it. For example, 3 times 4 is this right here, and 3 times 2 is it's right there, plus 4, which is right there, which equals 12 plus 6 plus 4, which equals 22.
equation, an expression with an equal sign. 2 plus 3 equals 5. So, yeah.
Elimination method. Here's an example. Y equals 6x plus 5 and y equals 3x plus 2. In order to use elimination method, you have to subtract. So right here is going to equal y equals 3x plus 3.
Equivalence, something that is equal to each other. 4 plus 6 equals 5 plus 5. Unit 4, exponents. Area is basically the surface of a figure. So in this case, to find the area of a square, you do a times a, or a plus a plus a plus a. So an example would be 4 times 4, which is 16, which is the area of the square, or 4 plus 4 plus 4 plus 4, which is also 16. So yeah. And the diameter is basically the line that goes through the circle. The space around it is the circumference, which is basically the perimeter around the circle. And then yeah, a cone is this figure over here. To find the volume of a cone, you do pi r squared h divided by 3. This is the height of the cone. And this is a cylinder. The cylinder, to find the volume of a cylinder, you do pi r squared h. That's the height too, and this is the radius. The radius is basically half of a diameter. The sphere is what's over here. To find the volume of a sphere, you basically do pi r cubed 4 divided by 3. Volume is length times width times height. So basically, this is it. An example is, since this is the height, this is the width, and this is the length. So 4 times 4 times 4, 4 times 4 times 6 will equal 96 cubic inches, which is the volume of the cube. Scientific notation is basically a way to shorten big numbers and write them in a simple way. So 1 million written in scientific notation is 1 times 10 to the 6th power. 1 million itself is written in standard notation over here. Product of power property is basically when you're multiplying two numbers that have the same base but different exponents, you add the exponents and the base stays the same. So in this case, 10 to the 2nd power times 10 to the 3rd power will equal 10 to the 5th power. Zero exponent is basically anything to the 0 power equals 1. An example is 10 to the 0 power is 1, 100 to the 0 power is 1, 20 to the 0 power is 1, 1 to the 0 power is 1. Exponents is that little number on top of the big 5. The big 5 is basically the base. The exponent basically states how many times you have to multiply the base to get a certain product. So basically that's the power. In this case, it will be 5 times 5 times 5, which is 125. Decimal notation states number in front of the decimal has to be between 0 and 9. In this case, an example would be 19,234. Written in scientific notation is 1.9234 times 10 to the 4th power. See, this is written in decimal notation because 1 is between 0 and 9. So, yeah, this basically 10 to the 4th power is the power of 10. Negative exponent and simplify. So, 2 to the negative 6th power, this is a negative exponent. 2 to the negative 6th power simplify into 1 over 2 to the 6th power is that.
Today we are gonna talk about unified rational and irrational numbers.
Go.
Constant, occurring continuously over a period of time. Example in algebra, a constant is a number on its own or something, a letter such as a bracket to stand for a fixed number. These are some examples. I think there are. Okay, number 4 is yeah, you can read it. Okay. Coefficient, a number used to multiply by a variable. Example, 6z means 6 times z. 6 times 2, it was 2, not z. A 2, and this 2 is a variable, so 6 is a constant. Sometimes a letter stands in for the number. Cube root, the number that produce a given number when cubed. The cube root of a number is a special value that when used in multiplication 3 times given the number. Example, 3 times 3 times 3 is 27, so the cube root of 27 is 3. A cube, what you get when a number is used in multiplication 3 times. Example, 4 times 4 times 4, no, it's 4 times 4 times 4 equals 64, so 64 is a cube/perfect number. A cubic unit is a measure of volume. It is equal to the volume of the cube, which is 1 unit tall, 1 unit wide, and 1 unit long. A cubic unit is a measure of volume. It is equal to the volume of the cube, which is 1 unit tall, 1 unit wide, and 1 unit long. A distance formula is driven by creating a triangle and using the Pythagorean theorem to find the length of the hypothesis. The hypothesis of the triangle is the distance between the 2 points. So here I made an example. So yeah. This is a hypotenuse, the longest side of a right triangle. So this is the longest side of the right triangle, and these two areas, A and B, are the legs, and the hypotenuse is usually called C. So these are the pictures. Inequality. Difference in side degree and inequality say that two values are not equal. A, see, this is not equal. B said that it's not equal to B. Yeah.
Evaluate to solve an equation.
Unit 6, bivariate data. Bivariate and univariate data. Bivariate means 2 variables, and univariate means 1 variable. Categorical data. Observations only classified in categories. Example, gender, male and female. Correlation. It could be either negative or positive or no correlation. For example, this is a negative correlation, this is a no correlation, and this is a positive correlation. Frequency are also waves, something that is repeated over a particular period of time. As you can see, this is a high frequency, this is a medium frequency, and this is a low frequency. A frequency table is a table that shows the total for each category or group of data. For example, this is a frequency table, and these are classified in it. There are 2 frowny face, 4 hearts, and 1 smiley face. This is a two-way table, and it's also a bivariate data because it has 2 variables. So the part marked in red is the joint frequency, and the total 60, 40, 100, 36, and 64 is the marginal frequency. This is a scatter plot, and it's called a scatter plot because the points inside the graph is scattered,
This is an outlier because it's away from the other points. The line going through it is the line of best fit. The line of best fit is basically the line that fits the graph the best.